and we can calculate the thermal conductivity. And here you can see the test result. And we can see the thermal conductivity from the PCB board and the thermal conductivity of the insulation layer. If you have any solid material or thin film material that you cannot prepare the three thicknesses, and you can use the same way to acquire thermal conductivity. Here are the main functions of the TEAM tester manufactured by Longwing. This TEAM tester is based on ASTM D5470. And second, with the delicate design, it has good repeatability and reproducibility. And the third point, it is suitable for measuring thermal impedance and conductivity of the typical TEAM materials, such as grease and pad. And the fourth point is about its accurate thickness measurement using LVDT sensors. And the fifth point, the tester will have automated setting for press load and input power. The sixth point, and also we can set the temperature of hot surface, cold surface, or average temperature with automated setting. This tester is also suitable for reliability tests. And all the data will be exported in Excel. That means you can make your own report easier. Here we are going to explain more applications of this TEAM tester. And the first figure you see is for the reliability test. Take thermal grease as an example. Sometimes the CPU will run at higher power and sometimes lower. With different heat load, will have different temperatures. And the operators will try to avoid the pump out scenario. If we have a significant temperature difference of the chip, the pump out scenario could happen. That means the thermal grease will be released between the interface of chip and heatsink. So in this case, we can use the TEAM tester to conduct a reliability test. So we can input the high temperature and the low temperature and measure its thermal impedance over time. And in the end, we'll know under the long term how the thermal grease will perform and its variation of thermal impedance. And the second application is to see the influence of press load to thermal pad. So the same from the software, we can set different press loads and measure their thermal impedance. So we can get the figures like this. And now we are looking at the result of gauge R&R, which means the repeatability and the reproducibility. So here we find 3 different samples and different operators to measure the thermal impedance and to do the analysis. This is the result we did before, and the result was about 3% of gauge R&R. In fact, Customers of Longwing shared with us about their result, and we can conclude that the reproducibility and the repeatability of Team Tester from Longwing is around 5% of gauge R&R, which is pretty satisfying. In general, if the gauge R&R can be lower than 10%, it can be considered as a good apparatus. Now we are going to talk about the precision analysis of ASTM D5470 standard. People could have a very high standard on high expectation of this test method and expect that the thermal conductivity could have a very low deviation, maybe 1 or 2 or 3%, but in fact it's not the case. This is the result from the standard itself. There are 5 materials at different laboratory, and you can see the standard describes the deviation of the test samples and the apparatuses from different manufacturers, even though all of them claimed to follow ASTM D5470, but the deviation of themselves could be 4 to 10%. If among different laboratories, we can expect there will be even higher deviation, could be 10% or even higher. So this is the approximate deviation range if you use ASTM D5470. On the previous page, we see the general deviation if we follow ASTM D5470. And now we'll take a look at the Team Tester of Longwing. So here is the table to show the general specification. The first row is about the thermal impedance. The measuring range of thermal impedance for Longwing's Team Tester is from 0.01 to 50 degrees C square centimeter per watt. And the accuracy is 0.005 or 5%, whichever is greater. In general, if the thermal impedance of grease can reach 0.03, could be very good. And the best thermal grease we tested is around 0.03 of its thermal impedance. So right here, we can consider the thermal impedance 0.03 to 0.04 could be thermal grease with good performance. And regarding the deviation, actually 0.03 and 0.04 could be at the same level. So here we define the deviation is plus minus 0.005. And the second row is about the measurement range of thermal conductivity, which is related to thickness. So here the criteria to see the range of thermal conductivity is that the thermal conductivity divided by thickness, which unit is millimeter, should be smaller than 30. And also thermal impedance is an important factor, so we have to consider thermal conductivity along with thickness. Take one example. If the material has the thermal conductivity 30 watt per meter per Kelvin, the thickness, proper thickness should be 1 millimeter or higher. If the thickness of the sample is smaller than 1 millimeter, that means it may be not suitable to be tested. And the second criteria is about the thermal conductivity should be higher than 0.1 watt per meter per Kelvin. And the deviation is plus minus 0.1 or 5%, whichever is greater. The third rule is about the press load. The controllable range is from 8 to 100 psi, and the accuracy is plus minus 0.5 psi, and the control accuracy is plus minus 1 psi. And the fourth rule is the thickness range from 0 to 4 millimeter. The accuracy is 0.005 millimeter, and for the thickness control range, there will be 0.01 millimeter. For the temperature range, we only define the hot surface temperature. The suggested range is from 40 to 100 degrees C. The measurement accuracy, 0.1 degrees C, and the temperature control accuracy, 0.5 degrees C. That will be all for the specification of Longwing's steam tester. And this will be all for our presentation today. If you have any further questions, please welcome to contact us. Thank you so much.